Hello and welcome to SudoKanard. We're here to solve this killer Sudoku, which was created by Jan Vondruška for the Czech Sudoku Championship. It was featured in a round full of mathematical variants. I absolutely loved this round. I don't know how many puzzles I will solve on video from this round, so here I just highlight the fact that those cages spell 20 and then 24. Oops. Like this. So it was very well done. It was a rather difficult Kira Sudoku. That's a variant I'm very well acquainted with, and it took me some time to solve it during the test solving and during the preparation for this video. I did not solve it 10 minutes ago. It was a few days ago when I created the Pempa interface, and I will leave the link in the description. So I didn't add the rules of Kira Sudoku, but here they are. In such a cage, all digits must be different. Well, it's obvious for this cage with the rules of Sudoku, but it's not so obvious for this cage, which spans to sorry. I mean, in normal Sudoku, this and that could be the same digit, but inside the killer cage, this is not allowed, and this plays a part only here and there. And the number in the corner is the sum of all digits in such a cage. So where do we start? A place to start seems to be here. The sum of all 6 digits here is 22, and the sum on a whole row, the sum of all digits from 1 to 9 is 45, so that the sum of those 3 digits is 33, which can only be achieved by 6 plus 8 plus 9. This is something you need to know when you solve Kira Sudoku. So only 6 goes there. We are left with 8 and 9, but to fulfill this 15 sum, 9 won't work. It will require 6 to repeat in this box. So this is 8, this is 7, this is 9, which is a rather nice beginning. 8 has 2 options, which are 1, 2, 5 and 1, 3, 4. This is something else that you also need to know if you solve Kira Sudoku. So at this point we can only say that 1 is somewhere in here. Sorry about that. Something interesting is that 22 plus 12 is 34. And something that should be well known if you solve Sudoku, if you solve Kira Sudoku, is that the only decomposition of 34 with 5 digits is 4, 6, 7, 8, 9. And now from those 5 digits, there's only one way to achieve this 12, and it's 4 plus 8. So that this is 6, 7, 8, 9. Sorry. What could be interesting next? So there is a 1 here. 7 must be here on the row. One of them will have 2 and 5. The other one will have 3 and 4. 7 with 3 digits has to be 1, 2, and 4. There are 2 ways to achieve this 15 clue, namely 6 plus 9, 7 plus 8. I don't think that this can be found at this point. A point of interest is that the sum of all those 8 digits is 36. And that is actually not interesting at all, I'm afraid. The sum of all 8 digits here is 45, which means that this digit is the sum of all 2 digits here, but that doesn't seem to be that useful. So those digits in the column that remain are 1, 2, 3, and 5. Only 3 and 5 work there. 3 would be with a 9, 5 would be with a 7. It means that those 3 digits must be 6, 7, and 9, and that the 6 is in here, so that we can remove the 6 here. This 6 can either be 1, 5 or 2, 4. '21 has 3 decompositions. 4, 8, 9, which will be impossible here because, well, 4 and 8 would have to be both in this cell, so that doesn't work. There's 5, 7, 9, and 6, 7, 8. So those are the options. So those are digits between 6, 7, 8 would put the 8 there, 6, 7. Well, let's just explore that option. 6, 7, 8. In this case, 8 must be the sum of those 2 digits, so they have to be 3, 5, and here we get 1, 2, 9. That seems to work perfectly. So this looks like a valid option. What about 5, 7, 9? Something of interest here is that 12 is an even number. 4 and 8 are not available. You can't put 3 odd digits in such a case because the total would be odd. So there has to be an even digit, but only one. So we saw earlier that 2 would work with 1 and 9, so that's an option. 2 could work with 3 and 7, in which case 7. Oh, I didn't see that. There is a 7 in this 21 clue, but 7 is not here, so 7 has to be here. All right, so 2, 3, and 7 is not an option. So we are left with 1, 2, 9 as an option. With 7 and 6 here, 3 and 5 here. So what if 6 is in there? If 6 is in there, this is a 1, 5, and 6. So that 5 and 6 are both excluded from here. In this case, we get 7, 9, 5 here. This is a really oh, and does it work? No, it doesn't work because then this 6 must be 2 and 4. This 7 must be 1 and 6, and there's no value. There's a conflict here. Well, this is completely far-fetched. I have no memory of doing this kind of reasoning, but I think it shows that the only option for 12 is 1, 2, 9. Well, there's probably something smoother to solve this puzzle. Well, what about the rest now? So 7 here. So this digit is the sum of those two, so it's never 5, it's never 6, because 5 couldn't be 2 plus 3 or 4 plus 1 with the digits here. 6 doesn't work either. 6 would have to be 2 plus 4, 1 plus 5. I definitely did not do such complicated reasonings when I test solved the puzzle. But let's move on. So 5 and 6 are both excluded from this cell. So 5 and 6 are here with the 7. This is 8 or 9. We have a 3 somewhere here together with 5 or 6, according to what goes there. So 3 is in here. with 5 or 6. And I should remove that because this is not what's happening. Perhaps I should have a look at this. The total sum here is 17. There are 2 ways of achieving 17 with 5 digits. They are 1, 2, 3, 4, 7, but this would need those to be 2, 3, 4, and those to be 1, 7, which would not work. So this is not an option. The other option, which has to be what is found here, is 1, 2, 3, 5, 6, but then there are 2 options. 3, 5, and 1, 2, 6, 2, 6, and 1, 3, 5. And an interesting point here is that this contains the 5 or 6 that is missing from that, from there. Madame is certainly doing something much too complicated. Oh, something I've been missing that is much less complicated is the fact that in this box, 8 can only be around here. 8 will never be in those cages. And if you look at this box, now 8 can't be here, can't be here, can't be here, and can't be in the 7 cage. So 8 had to be here all along, which means that those digits are 6 and 7, and those digits are 3 and 5, and I could probably have found this much earlier. So now this is 1, 3, 5, and this is 2 and 6, and actually 6 at the bottom and 2 here. So I've definitely done something much too complicated. Something that I'm seeing now is that 2 does not appear in this 14 cage. And the minimum value you can make without using the 2 and with using 4 digits is 1, 3, 4, 5, which is 13. So the only way of achieving 14 with 4 digits without using the 2 is by upgrading your 5 to a 6. So this is a 1, 3, 4, 6 quadruple, except that this is not true. Oh, actually, this is not a 5, 6 pair, this is a 3, 5 pair. So I was saying 1, 3, 4, 6. 3 is not in here, 1 and 6 are not here, so 4 is not here. Now 4 is somewhere here, so this is 8, this is 4. Here I need 2, 7, and 9. Here I need 8. What am I doing? Not 3, 7, 9. No, 2, 8, and 9. Those are 7 and 5. This row needs a 9 and a 4. This row needs an 8 and a 7. Well, where do we go from here? So what are the options? If I put 1 and 5 into the 6, then this can only be 3 and 4. But with 1, 5, 3, 4, there's no option for this cell, so that doesn't work. So the 6 is with 2 and 4, and the 7 is with 1 and 6. There's a 1 in here, so that's the 6 at the bottom, the 1 here. It disambiguates some of the cells, and this digit here found its counterpart in this cell. This 7 now tells us that this 15 cage is not 7, 8, it has to be 6 and 9, and I'm saying that this one here puts a 1 into this cell, and a 6 here and a 1 there. and that's not a 9. So here we get, this is 21, 35, so we need 10 with those two cells, and seeing all that, the only option is 3 plus 7. Knowing that those digits, well, this has to be a 1, and those are 5 and 8, which means that 12 is done with 3 and 9. So this is 6, this is 7, this is 9, this is 9, this is 6. Those are 8 and 5, meaning that this is finally 3, 5, 3. Those must be 1 and 4. In this order, yes, my phone is vibrating. People will have to wait. 7 can only be here on this column. This is 2, this is 5. Now, this is 2, 5, and 7, so 2 goes there. So this is 8. This column still needs 3 and 4. This cell can only have an 8, which disambiguates a lot in those columns. 2 and 4, 9 and 2, 9 here and 6 there. This row needs 3 and 4. There's a 4 here, so that's the 3. That's 4, that's 3. And at this point, 16 is there to help us complete the solve. So here I need 2, 4, and 5. Here I need digits from 3, 5, 8, and 9. 9 can only be here. Here I need digits from 2, 4, 6, 7, so this can only be a 4. I think this indicates a lot then. This column is 1 and 3, so this has to be the 1. This row needs 6 and 7, so this is 7, this is 6. 7. This can only be a 3 now. That's a 2. So this is from 5, 8, and indeed this 16. This 16 sum tells us that this is 5, 8, 5, 8. And this completes the solve of this pretty difficult Kira Sudoku. Again, I wouldn't bet on my finding the shortest path. All this complicated study I did over there with a look ahead that is really, really complicated was probably not needed. This logic with 8 was most probably expected, and my bet is that it helped tremendously shorten the solve. And this is perhaps what I did find when I test solved the puzzle. Well, anyway, this is my video. Thanks for watching it, and see you soon on SudoKanard.